Hello everyone, Mr. Fawcett here, and we're back with another Algebra 1 lesson. For the past 4 videos, we've talked about graphing lines. Today, we're going to go the other direction, and we're going to be looking at a line on a graph and seeing if we can come up with the equation that represents that line. So let's just hop right in. To get you started, you have 2 multiple choice questions, and you're basically trying to decide which of those options represents the line on the graph above it. So take a minute or two to think about it, see if you can eliminate any options, even if you're not sure which is the correct one, and then join us for a discussion. All right, so if we look at graph number 1, we know that the y-intercept is at 2. So we can eliminate all the equations, and these are all in slope-intercept form. We can eliminate all the ones that have a y-intercept of something other than 2. Okay? Now, our 2 options that are left, A and C. One says it has a positive slope of 1/2, and the other says it has a negative slope of 1/2. Well, if we just know whether this slope is positive or negative, we can determine which answer is correct. Again, if you forget what's positive or negative, you can think of somebody walking uphill. That represents a positive slope. If they were going downhill, that would represent a negative. So C is our correct answer. If we wanted to actually figure out what the slope was, make sure it was positive 1/2, we could look at the change in y over change in x. So if I look at these 2 points here, my change in y is +1. My change in x is +2. Right? So that would give me change in y over change in x. Right? Those triangles represent delta y or delta x, and delta means change in, so we have 1/2. So C would be our correct answer. Okay, moving on to number 2. Our y-intercept is -4, so we can eliminate A, B, and C. Well, if we can eliminate those 3 choices, we know that D has to be our correct answer. We can also check out the slope, though, to make sure it makes sense. We do have a slope that should be negative. We can think of somebody walking downhill. And we can also check to make sure that it is indeed -3/4. So let's find another point here and look at the change in y over change in x. So I'm going up 3 for my change in y. So change in y is equal to +3. And I'm going to the left 4, which means my change in x is -4, which is equal to -3/4. So this slope checks out. Okay, let's move on to some more complicated examples. Here, it's not multiple choice. You now have to come up with the equations yourself. So go ahead. You can write your answers in slope-intercept form. Let's fix that word. It's already fixed on your sheet. Write your answers in slope-intercept form by finding the y-intercept and the slope. Okay, so we are just going to do the one on, let's do the one on the right, actually. They're both very similar. So we know that slope-intercept form is y equals mx plus b. Let's go ahead and find that y-intercept first. And that is right down here at -5. So that's the point 0, -5. So b is equal to -5. Let's find the slope now. So let me find another point on this graph. We can come up here. And let's look at the change in y over change in x. So change in y, well, we are going up 8. So that's +8, and we are going over 1. So my change in y is equal to +8. My change in x is equal to +1 because we're going to the right. That gives me a slope of 8. So my y-intercept was -5. My slope is 8, so I get y equals 8x minus 5. Let's put those a little closer together. Y equals 8x minus 5. Okay, let's move on. Again, now we're going to make it a little bit more difficult. If we look down here, I would go ahead and take a minute and just look at what the problem might be when you're trying to write out your equation of this line. So right away, you may see that, well, the y-intercept is somewhere between 1 and 2, right? We don't know exactly, oops, let me get my pen out. We don't know exactly where though, right? We don't want to guess and say it's exactly at 1.5 because it could be at 1.55, right? So we have to come up with another way of finding the equation of this line rather than just being able to tell where the y-intercept is. When you are not given a very straightforward example, right? The examples above were very straightforward. You could count the change in y over change in x to find the slope, and the y-intercept was clearly given because it went through an integer, right? It wasn't a decimal, it wasn't a fraction. When that is not the case, we are going to use point-slope form to write the equation of our line. And you'll see why this is fairly straightforward. So point-slope form. Hopefully we remember that that is y minus y1 is equal to m times the quantity x minus x1. So to come up with point-slope form, we need to come up with an x1, y1. So we need to have an x1, y1, which is just any point on the line. And we need to come up with a slope, right? We need to come up with that m. So let's start by picking a point, and it can be any point, right? It does not have to be a specific point. So why don't we just start up here with a, which is at -2, 4. Let's fix that. -2, 4. So my x1 is -2, my y1 is +4. Let's put those into our equation. I get y minus 4 is equal to m, which I don't know yet, so I'll leave it blank, times the quantity x minus -2, right? Because it's minus x1, so it's minus -2. We'll simplify that in a second, but let's go ahead and try to find our slope. Well, I have 2 points, right? I have this point b down here at 2, -1. So I should be able to count the change in y and the change in x. Change in y is going to be +5. Change in x is -4. So my change in y over change in x is equal to +5 over -4, which was just -5/4. This is our slope. And I can inject that, or I can substitute that in for m. So -5/4 is my slope. Now, I can just simplify my equation. Y minus 4 is equal to -5/4 times the quantity x plus 2, because it was minus -2. And here is the equation of my line, right? It does not say we have to write it in slope-intercept form. So if we don't have to write it in slope-intercept form, we can just leave it in point-slope form. Now, here's the thing. With point-slope form, the equations of the lines can look a little different because I can use any point that I want. So another example, right, I could have also said, and I'll do that over here, y minus y1 is equal to m times the quantity x minus x1. Well, if I had chosen the point 2, -1, which was b, right, my answer is going to look a little bit different. I'm going to have y minus -1 is equal to -5/4 times the quantity x minus 2. And after I simplify, I'd get y plus 1 is equal to -5/4 times the quantity x minus 2. Now, here's the thing. These two equations represent the same line. Okay, if I put them into slope-intercept form, they would end up being the same. All right, slope-intercept form is always going to look the same. When you have point-slope form, they can look a little different because we're using different points. Now, I think it's probably valuable to show you that these come out to be the same when we're talking about slope-intercept forms. So I'm going to go ahead and show you that. If you're unsure of how I got these equations, though, pause the video and kind of go back through, maybe need to rewind and listen to the explanation one more time. But let's go ahead and show you why these are actually the same. All right, so I have both of my point-slope forms down, and now we're going to convert it to slope-intercept form. So the first thing I'm going to do is distribute. So I get y minus 4 is equal to negative 5 fourths x. This is going to be minus 10 fourths. Okay. Then I'm going to add 4 to both sides. And you can actually, and I'm actually going to simplify this to a decimal first to make it easier to understand. So 10 over 4 is really 2.5. Then if I add 4 to both sides, I get y is equal to negative 5 over 4 times x plus 1.5. And this makes sense because if we look at our graph over here, our y-intercept is somewhere between 1 and 2, and 1.5 is certainly between 1 and 2. Let's make sure we get the same thing with our pink equation. So I get y plus 1, and then when I distribute, I get negative 5 fourths x plus 10 over 4 this time. I'm going to simplify that. So y plus 1 is equal to negative 5 over fourths x. And when I say simplify, I actually meant just convert the fraction to a decimal. It's going to be positive 2.5. And I'm going to subtract 1 from both sides. And I think you can see that this is going to turn out to be the same. 2.5 minus 1 is going to be plus 1.5. So again, when I convert my point-slope equations to slope-intercept, they are always going to look the same. But because I can choose different points for my x1 and my y1 in point-slope form, my point-slope forms can look different. They still represent the same line, though. Okay, let's move on. So before, right, in the equation above, I did not know what my y-intercept was. So I had to start with point-slope form before I got to slope-intercept. Here, you'll notice even a further problem, right? I'm not able to count the blocks here for the slope, right? I can't count the change in y and the change in x. So I'm also going to have a method for finding slope other than counting. So to start off, I always like to write down my general equation so that I then just have to worry about substituting in for m and x1, y1. I think we should just fill in the x1 and the y1 first, right? You can take your pick. I will use the 13, 9. So my x1 is going to be 13. My y1 is going to be 9. I can start rewriting my equation. y minus 9. Oops. Y minus 9 is equal to m. I don't know what that is yet. Times a quantity x minus 13. So I need to find this slope. And right, I can't just count the change in y and the change in x. I wrote those opposite of what I said. I did the change in x first. Because I can't count the blocks because, one, this point starts in the middle, right? But the tick marks are also counting off by 5s, right? So it's going to make it a little bit more complicated. So what I need to do is employ the slope formula. Well, we already know what slope is, right? I know that slope is equal to the change in y over the change in x. Well, maybe you've seen this formula before, but the change in y is really the difference in the y values. y2 minus y1 all over x2 minus x1. Well, where do you think we get our x1, y1 and x2, y2? Well, from these points, right? We already labeled our x1 and our y1. Now I just need to label my x2 and my y2. And this formula works for any 2 points that are on the line, because the slope will be the same between any 2 points. So then I just have to do some substitution. So my y2, now I still think I labeled that as 2 up here. Otherwise it was a poor 1, y1. My y2 is 0, minus y1, which is 9. My x2 is negative 2, minus my x1, which is 13. So I end up getting negative 9 all over negative 15. Because I have a negative divided by a negative, that's going to be a positive. So this is equal to positive 9 over 15. We could actually simplify this, right? 9 over 15, we could divide both of those numbers by 3. I'm going to do this down here. So I would get 3 over 5. So 3/5 is the slope that I'm going to use up here. Again, it does not tell us we have to put this in slope-intercept form, so I could just leave it, right? I don't have to convert it if it doesn't ask me to. I don't have to do any extra algebra. The main thing from this problem, though, right, is this new slope formula. And it may not be new. You may have certainly seen this equation before. But we are going to need to know how to use it. You're going to use it in this class. You're going to use it in geometry, algebra 2, pre-calc, and all the way up to calculus. Right? So it's something that we're going to use pretty consistently, and we need to know how to work with it. Let's go formalize that down below. Right here, the slope formula. So again, slope is equal to the change in y over the change in x. The change in y is the difference. It's the change in the y values. Right? y2 minus y1 over x2 minus x1. So when you are not explicitly given the slope and or the y-intercept from the graph, then you can build your equation using point slope form. Right, and that's the y minus y1 is equal to m times the quantity x minus x1. This is the equation that you are going to use most frequently in upper level math classes. And that's because you're rarely just given the y-intercept right off the bat, right? So it's hard to go from, or it's not as easy to start with slope-intercept form. You will, though, be able to find at least 2 points, which will let you find your slope using our slope formula right here. And then you can always use one of those points for your x1 and your y1. So it just makes sense that we generally start with point slope form, and then if we have to, we can then convert to slope intercept form afterwards. But again, that's only if the question requires it, right? There's no need to do extra converting if we don't have to. Okay, that does bring us to the end of this lesson. We will do some more practice in class with not only finding slope, but building equations of lines using that point slope form. So until then, enjoy the rest of your day, and I will look forward to seeing you next time.